Uh, oh, I've got a disclaimer here, and the disclaimer here is not out of courtesy for VMUG, but it's because I will be showing you a couple of things that are going to be new in the upcoming years. They may or may not be released in the upcoming months or potentially years. And what I would like to ask you is, if you're making purchasing decisions, please don't base those purchasing decisions on what I'm telling you today, because these plans may end up changing. So let's get started. Who still remembers this? Anyone? Anyone? No one remembers the easy life? Well, I remember the easy life. I started out doing vSphere, or actually I started out doing ESX in the 2.0 days. And life was relatively simple back then. You had something called a MUI. And the MUI was the interface for ESX. It was a single web-based interface. And you actually used it to manage a single server. And in my particular case, I had a dozen virtual machines running. Later, I started to be responsible for a couple of hosts, and we had 50, 60 virtual machines. You know, back then, life was relatively easy. I had a couple of virtual machines to manage. I had some shared storage, 1 or 2 days. And the biggest challenge is when you're doing upgrades and you went from 2.5.4 to 3.0, definitely running a Clarion, then you may have experienced some similar issues I experienced. But life was relatively easy. If you look at the world today, the world is changing rapidly. What we've actually calculated, or what IDC has calculated together with Dell EMC, I should say, is that there has been a 50 between 2010 and 2020. So we're not even still there yet. That also means that the way you've been managing systems probably will need to be changing over the course of the upcoming years. Or hopefully you're already going through that particular change. Reality is that things are moving fast. It's actually moving at such an enormous pace that we are predicting that in the upcoming 5 years, you will be deploying more applications and solutions than you've done in the past 40 years. Now think about that for a second, and think back to all the moments over the past years that you spent in the data center in the evening, or maybe over the weekend, doing maintenance and upgrades, doing provisioning of new virtual machines or applications, and then think about the upcoming 5 years, what's going to happen if you'll be doing 5, 6, 10 times more work than you've done in the past 40 years, right? It's kind of ridiculous. And the reason that is happening is because of all of these different changes in the industry. I was in Dallas yesterday, as Brad mentioned, and the morning keynote was actually done by Ray O'Farrell, and he spoke about the Internet of Things. Now, a lot of people in the room said, well, you know, sounds interesting, but our company doesn't really do anything with the Internet of Things. But if you look at the majority of companies I talk to, a lot of the larger companies that I talk to, although the infrastructure people are not aware of the fact that their company is doing something with the smart devices, the application people are usually aware of that particular fact. What we're predicting, or what IDC is predicting, is that there's going to be 50 billion of these internet devices connected to a network in 2020. That data, at some point in time, will need to land somewhere. And potentially, you as an administrator will be responsible for that. Now, you can imagine that if you have a couple of hundred virtual machines right now, the amount of data that they produce, you know, is probably in the terabytes. If you're fortunate, maybe a petabyte or something like that. But if you have 5 million devices, smart meters, for instance, electricity meters, connected back over to the network, delivering data back to the network, based on which you're going to bill your customers, then the amount of data that you're generating is probably going to be significantly more. Now, on top of that, we're also starting to see a shift in the industry where we're starting to see workloads moving towards the edge location. So what does that mean? Well, over the past couple of years, everyone has actually centralized all of their workloads typically into one single large data center. But what we've realized, and especially with these IoT devices, but also remote offices and you name it, that certain services are better off running locally, right? You can imagine that if you have a remote office, and for every single DNS call, it needs to go across the wire, across the internet, to the central data center, do the call and then come back. That is going to take a significant amount of time just to browse the internet. So for those purposes, you may want to have a DNS server locally. But there are other reasons as well. If you have a factory, for instance, and some of the data that's being generated in the factory needs to be analyzed, and action needs to be taken on that particular data, you can't be shipping that data across the wire constantly and then analyze it and then ship the results back. It's just going to take too long. So in those particular cases, what we're starting to see, what we expect, is that a lot of the workloads that are now running centrally will start moving over to these edge locations. And then there's another thing happening in the world of IT today, and that's machine learning and artificial intelligence. Now, I'm not going to talk about it because it's not my expertise, but it is something that is rapidly changing the world. And it is also something that's going to generate a massive amount of data, but also going to consume a lot of compute. Now, the interesting thing here is that if you look at all of those different things happening in the industry, the world is moving at an extremely rapid pace. I think we can conclude that. I think we can all agree that that is the fact. However, when I talk to my customers, most of them still create lunch. Is anyone a storage administrator in the room? Okay, it's a pretty big number of storage administrators, so I need to be careful what I'm going to say next. But, I mean, the reality is people still create LUNs, and when they've created a LUN, the virtualization administrators come in, and they open a spreadsheet, and they try to figure out where to place the virtual machine. Now, just think back to the examples I gave about the new types of workloads. It's not going to be feasible to open up a spreadsheet every single time you need to provision a virtual machine. It's just going to take too long. On top of that, it's also relatively error prone. I've seen customers where they were supposed to deploy virtual machines on top of a data store that was replicated to another location, or was stretched across multiple locations. But they ended up provisioning the virtual machine to a data store that wasn't stretched or wasn't replicated. And now when they needed to do a failover as a result of a disaster happening in their data center, those workloads were actually unprotected. So all of the data literally was unavailable and they had to go back to tape. It took them multiple days to actually store the data, and as a result that cost them multiple millions of dollars because of the downtime of that particular service. So these are the types of things that can happen. And then last but not least, and most of you probably recognize this, is you have to install an ESXi server, and you open up a Word document, and you go through the different procedures that are available, you type these commands that one of your colleagues at some point in time figured out. And usually what happens halfway down that particular procedure, there's a mistake in the particular command. Or something has changed in your infrastructure, a VLAN has changed, or whatever it is, and things just don't work. Now, if you think back to what we just discussed, and you see these different types of screens, I think it's realistic to say that things need to change. And things are changing. Actually, VMware has been changing a lot of things over the course of the past 20 years, because that's how old we are. We started out by virtualizing a lot of physical machines, making it easier for you to actually deploy new instances of Windows or Linux or whatever it was. On top of that, we introduced something called vCenter. And vCenter allows you to enable functionality like HA in the US, where you can automatically migrate virtual machines between hosts based on a load, or where if a host would fail, virtual machines would actually automatically be powered on. Really cool functionality that wasn't available before VMware existed. Now we did another thing, and we actually started talking about that a couple of years ago at VMware, which is called the SDDC. And with the SDDC, what we more or less announced was what we would be doing for compute, we would also start doing for network and for storage. On top of that, we will start layering an additional layer on top of it that will allow you to monitor and manage the systems in a smarter way by using the vRealize stack. That is something that we've been doing over the past couple of years. But the other thing that we are now doing, and that is something that we're now focusing on, is making sure that from your perspective, when you think about your environment and you have both an on-premises environment and a cloud environment, whether that's VMware Cloud on AWS or maybe they are edge locations in an edge cloud, that you can actually consistently manage those different types of systems. That is something that is one of the focus points of VMware as it stands right now. The other thing that we're focusing on is actually connecting all of the different locations, if you have multiple locations, through a smart solution called VeloCloud, which is the virtual cloud network that we are here referring to. Okay, so what does that mean? Well, what I'm going to be talking about today specifically is what we are going to do from a business unit perspective to bring it back to that easy life. Hopefully you can be the guy in the picture, or if you're a woman, then just think that that is a woman in this particular case. And you can just lean back and wait for things to happen, and VMware will take care of the rest, hopefully. So what I'm going to do today is I'm going to talk about vSAN in particular and how that may change some of the operational aspects of storage. But more importantly, what we are planning for the future. So what is coming in the future, which is vSAN data protection and vSAN file services. So let's take a look at vSAN. Before I get started, is anyone already using vSAN in this room? Any vSAN customers? Okay, quite a good number. So for those who are not vSAN customers or haven't heard about vSAN, what does it do? How does it work? Well, first of all, it's a fairly simple storage solution. If you talk to all of the customers that are here, I'm pretty sure that they can tell you the same story that I can tell you. The key thing here is the following. With vSAN, you don't have a dedicated storage system. What we end up doing is we grab all of the local storage devices, and they are usually flash or spindles, and spindles I should probably say, and we create a single shared data store out of those local devices. Now this is the key thing. You don't have multiple data stores for your cluster anymore. That also means that if you deploy a virtual machine, you don't need to open up a spreadsheet because you have a single shared data store available. It will always be the same data store. So that will result, hopefully, in simplified management. But on top of that, what it also brings is agility and scalability. Because what it allows you to do is actually introduce new capacity with every single host you're adding to the cluster. Or potentially what you could also do is if you would like to add only storage to this particular cluster, you can add additional disks to each of the hosts. And vSAN will simply recognize that there are new disks in the environment and add those to the capacity of the data store. Fairly straightforward so far, hopefully. Now the question that always comes then is, okay, how are you guys capable of building something that sounds so simple? Well, it's relatively straightforward. If you look at the majority of storage systems out there today, and it's probably the case for most of you, the majority of storage systems you guys are managing were built in the days when there weren't any virtual machines. There were only physical machines at that point in time. The other downside for most of the storage vendors is that there were only spindles. And these spindles will typically deliver 80, 90, maybe 150 IOPS at most if you were lucky. But in most cases, somewhere around 80 and 100 IOPS. So what they had to do was a couple of things. They had to introduce a rate for availability purposes, but also for performance purposes. On top of that, because you guys started deploying virtual machines, they had to start doing other things as well, like short stroking, white striping, creating extremely large disk groups, just to be able to give you a couple of thousands of IOPS, or maybe 15,000 IOPS at most. Now, when we started developing vSAN, and when other new storage solutions started to emerge, there was this new thing popping up, which was called Flash. And with Flash, the added benefit that you had from these devices was the fact that they could deliver 25,000, 30,000 IOPS easily in a SAS or SATA connected device at relatively low latency. On top of that, recently we saw this new device emerging, which is called NVMe, and these NVMe devices can actually do 100,000 IOPS, or maybe 150,000 IOPS at extremely low latency. Here we are talking about less than a millisecond latency. So you can also imagine that from a VMware perspective, but also for other vendors like Pure Storage, Nimble, Nutanix, Simplicity, that when they started designing their environments, or when they started designing their storage solutions, that they could simplify their storage solutions simply based on the fact that these devices could deliver more performance than each of you could probably ever consume. And now a new thing is happening. And it's a new device that is now slowly starting to emerge. And these things are called NVDIMMs, or persistent memory. Now persistent memory more or less already says it. It is a persistent type of memory, so it's a flash solution, but actually based on a DIMM module. So it sits next to the CPU. So what is the cool thing about this? Well, the cool thing about is the speed at which you can access these particular devices. If you would normalize the time, so I'm not going to talk about nanoseconds and microseconds and milliseconds, but I'm just going to talk about something that you can probably easier relate to. If a CPU cycle would be 1 second, then the access time of a persistent memory device would be 3 minutes. Now compare that to the traditional disk. It's going to be 6 or 12 months, right? That is a significant difference. I did the same presentation in France, and because they are not native speakers, I had a different comparison. The speed of a disk is a starfish. The speed of persistent memory is a space shuttle. That's the big difference between those two different types of devices. So you can also imagine that from our point of view, that from a storage stack perspective, we will need to start introducing changes as well. Because if you look at our storage stack, we have a similar problem that traditional storage systems have. When we developed our VMUG storage stack, there were only spindles available. So the overhead is relatively high compared to that persistent memory device. It is relatively low compared to the spindle. But as the world is moving towards persistent memory and towards all flash, we'll be introducing changes in our stack as well, and that also applies to vSAN. Part of that has already been delivered as vSphere 6.7 and vSphere 6.7 Update 1. Now I realize I've just spoken about performance for the past 5 minutes. I'm talking about hundreds of thousands of IOPS, maybe a million IOPS. And for those who don't know, this is Johan Cruyff, and Johan Cruyff is a football player. And as I said yesterday, football in Europe means something different as it means for you guys probably. So for us, football means kicking a ball, a round thing with your feet. For you guys, it's a hand-egg thingy. So it is a different thing. But the key thing here is the following. When Johan Cruyff spoke about football, and someone asked him the question, he said, I know a guy who can juggle a ball 1,000 times. Do you expect him to be a good football player? He said, well, if you can juggle a ball 1,000 times, you belong in the circus. A good football player can actually pass the ball at the right speed to the right teammate at the right point in time. That's what being a good football player is all about. Same applies to American football, of course, right? Throwing the ball at the right time, at the right speed is very important. Same applies to storage. It's great if you can provide 1 million IOPS, but any storage company can do that today. As long as you pay for it, they can deliver what you want. 1 million, 5 million, 10 million IOPS. It's all possible. If you can afford it, that's the question. The bigger question from a storage perspective is not the amount of performance that you're getting, but the way you're managing those systems. Because that's actually where the majority of time will be spent. So that's also from a VMware perspective where we have spent a lot of time. We've introduced this solution called Storage Policy-Based Management. Now this is not just available for vSAN, this is also available for traditional storage through the way of something that we call virtual volumes. Also, we have these host local data services that we call the vSphere APIs for I/O filtering, and they also consume the same platform. So what is this platform? Well, this platform allows you to specify within a policy what should happen to the virtual machines you are provisioning. So what does that mean? Well, just imagine in the world today, where you have a traditional storage system, you have 20 different data stores and they all have different capabilities. Some may be RAID 1 or RAID 10, RAID 5, RAID 6, replicated, not replicated, deduplicated, thin provision, you name it, right? So what we provide you with this policy-based management framework is the ability to specify all of those capabilities within a policy and then assign a policy to a virtual machine. Whether that's traditional storage or vSAN is even besides the point. So the great thing here is that if you deploy a virtual machine, the only thing you will need to do is select a policy that you've already created. So every single time you deploy a new virtual machine, you simply select a policy that is already available. And at the back end, vSAN or traditional storage system will then figure out how to place the virtual machine based on what was specified within the policy. Sounds pretty simple, hopefully. So this, I can tell you, if you talk to all of the vSAN customers in the room, or anyone that is using vVol in particular, this will definitely change the way you're provisioning virtual machines, and will definitely change the amount of work you have to do from a storage perspective and from a virtualization point of view. But let's get back to vSAN. What does it look like? Well, if you look at vSAN itself, when you deploy a virtual machine, and you deploy a virtual disk in this particular case, and you go to the interface, you just see a virtual hard disk. We've all seen this, right? If you haven't seen this, you probably ended up in the wrong room somehow. But in this particular case, you see a virtual disk, it's just a hard disk. It looks like a file, but actually is not a file. What this actually is an object. The object has a policy associated with it, and depending on what you specified in the policy, an X number of components of this particular object will be deployed. And then in the UI, of course, you can see where those components have been stored. So all of that data is available if you're a geek like myself and you would like to figure out which particular bit is stored on which particular disk and which particular host. All of that information is available in the UI, and you can consume that through the APIs as well. But the important part here is that vSAN is not a distributed file system, but it's an object store. Now, for vSAN itself, it doesn't really matter what type of use cases you have, whether it is a virtual disk or a business critical application, SQL or Exchange or maybe even Oracle. All of that can be deployed through the use of these policies, right? And of course, for the different types of applications, you will be creating different types of policies, because for Exchange, you may want to be able to tolerate more failures. Have something like RAID 6 or maybe a RAID 10 type of configuration across multiple locations being deployed. All of that is possible. The other thing that we can do with vSAN is something rather smart. Because if your data center looks something like this, it's a pretty neat data center. You know, the cables look quite nice. Usually the data center doesn't look like this, it looks like spaghetti. But if your data center looks cool like this, what you can do within the interface is actually specify where all of the different hosts are stored for your particular cluster. And if you think back to the previous diagram where we had multiple components for that particular object, what we now can start doing is actually place those components in each of the different racks. So if one of the racks fails, your data is still available. Pretty smart. And you as an administrator don't need to do anything about that. vSAN will take care of that based on the policy and based on what you specified within the UI, where your hosts are actually stored. This is something that we call fault domains. Now, if you're lucky, if you're fortunate, and you work on a campus that looks like this, right? You can imagine that we could do something similar for a stretched cluster scenario. So in this particular case, we can simply specify what the layout of the site is and mention that we're using building 22 and building 13. And now when vSAN starts deploying virtual machines based on the policy that you've created, it will actually store those particular virtual machines across these two locations. It's that smart. Okay, that sounds really cool, but how do you configure it? Well, let's go into the demo, because what I'm going to do next is I'm going to show you the vSphere 6.7 Update 1 interface, and this is a new interface that is going to be available in a couple of months, weeks. So what I'm going to do now is I'm going to create a cluster, and what you will see is that this interface looks different than what you've seen so far. Normally you would create a cluster and then you need to step through different types of workflows that are all situated in a different part of the UI, but in this particular case, when we've created a cluster, we immediately pointed towards the place where we can start adding hosts to the cluster as well. So we're going to select the hosts, and in this particular case, I'm selecting 8 hosts. I'm going to make those part of this particular vSAN cluster. After they've been added, you will notice that the hosts are added in maintenance mode. It sounds like something simple, but in the past, when you would add hosts to a cluster, they would be available immediately for workloads. If DRS wanted, it could immediately start placing virtual machines on those hosts. But what if there was something wrong with the host? The firmware wasn't updated. Well, you would have to update the firmware first, but you weren't allowed to because it was already being used. So that's something that we're preventing. The other thing that we allow you to do with this new particular interface is to configure all of the different services that you will need. Things like networking, so you can create a distributed switch. Select all of the different interfaces that need to be part of this particular distributed switch. You can add the VM kernel interfaces that you need for vMotion, the VM kernel interface that you need for vSAN, all of that part of the same interface. On top of that, you can start creating a stretched cluster. Now, I don't know if anyone in the room actually has a stretched cluster in the data center or not, but this is literally what it takes to create a stretched cluster. You select stretched cluster, I select some of the additional data services, then vSAN is going to tell me, okay, these are the disks that I have available in the host that are part of this cluster, so I'm going to select all of the different disks. And then the only thing I need to do next is I will need to select a witness host. Oh, let me define which host is part of which data center first, so that's going to happen right now. I'm selecting 4 hosts to be part of data center A, 4 hosts to be part of data center B, and then I'm selecting that witness. And this witness needs to be there in case anything happens to the network, so we need to make sure that we have some form of quorum mechanism. And that is literally it. So now we've selected the witness, we select the disk for the witness, and we're done configuring this particular cluster. So in this particular case, we have a cluster configured, we have the disks available literally within a second, and we can start deploying virtual machines. Of course, we need to start creating policies first, but what we've done now is we've simply created a stretched cluster environment. By show of hands, is anyone using EMC vPlex, network clustering, 3-part tiered resistance? Okay. Talk to that guy and ask him in a minute or after I finish my keynote how long it took to set up the environment. I can tell you, it's probably longer than longer than 2 weeks. And it usually requires the PSO team to set it up for you and do all of the testing. In this particular case, I literally did it in minutes. And you can do the same thing in literally minutes as well. Now, that's not where it stops. Of course, we have other things as well. It's not just about creating or adding hosts to a data center. Before I continue, can someone cut the music? Really? Okay. Yeah, if someone has a hammer, I can cut it myself. It's fine. Okay, so let's get going. So what else do we do? Well, installing and configuring a host is fairly straightforward, right? Setting up cluster, how often do you do it? Maybe 3 or 4 times a year, depending on what your job role is. In some cases, maybe once a week if you're a consultant. In some cases, maybe even once every 3 years. So what we did is we put a lot of effort and focus on the day 2 operations, as we call it. We have something called the health check. If anything happens to vSAN, the health check will call it out. It will inform you about the fact that a disk is dying, that your cache is filling up, that there are smart statistics ramping up because the flash device isn't behaving as it should be behaving. All of those different things are part of the health check. Of course, we have things like performance details. We have these different performance graphs that are available. And of course, we have things like capacity views as well, but I think that is pretty straightforward, right? It makes a lot of sense. The question typically is, okay, sounds cool, day 2 operations, I can handle that. But what if I have a support issue? So I asked the question yesterday, and there was one person that actually enjoyed it. So let's see what the experience is over here. Who in the room actually enjoys phoning up support? No one? Exactly, especially at 3 AM. No one likes phoning up support. It's probably one of the most painful experiences anyone can have. I used to be a consultant myself. I was a virtualization administrator just like you guys, and every once in a while you had an issue, you had to phone up support, or you had to phone up VMware or Microsoft or whatever it is, you always have the same questions. Can you please give me the log files? Yeah, I can give you the log files. So you download the log files, takes an hour or 2 or 3, they need to upload it, takes another hour, 2 or 3. Then they have the information that they need. Well, at least that's what you think. They typically come back and say, well, the information that I need is not part of this particular log dump. So can we wait for the issue to happen again? So you wait for a couple of days, the issue happens again. Your manager starts to get angry. You upload the log files again. It takes you another 6 hours. And you go over the same exercise typically 3 or 4 times. It's rather painful. So what we do within VMware, and that's something that a lot of people know about, what we in VMware, we actually have a program for the engineers, for our developers. And all the developers, or at least the lead developers, it's mandatory for them to actually spend a week with the GSS team, so with our support team. And they always thought that the support team had it easy, that they had an easy life. Believe me, those guys don't like asking you the same question over and over again. They don't. But they have to, because that's the information that they need to solve your problems. So our engineering team saw that, and what they started building is an interface for the GSS team. So this is not something that you will be able to see, but this is what the GSS team has to their disposal when you phone them up and you provide them the UUID of vCenter server. If you provide them the UUID of vCenter server, they can instantly see what the environment looks like. Not only can they see what the environment looks like, they can see some of the performance graphs, they can see some of the different alarms that have been triggered, they can click on the alarm, they can actually see what kind of issues were associated with the alarm. So they can point you to the fact that you have a particular incorrect version of the firmware or a particular driver running. So you can start solving that problem. The other thing that they're able to see is that they can actually see what has recently changed. Because we all know when you phone up support, they will ask you, has anything changed in the past week? And your answer is always going to be no. Exactly, I did the same thing. But now, they actually have all of that information available. So even if you tell them no, they simply click what has changed. They can look through the configuration and can exactly point out what has changed in the past week. It may or may not have anything to do with the problem that you're facing, but at least they have the information available. On top of that, the performance graphs that you have available, they also have similar information available, but a bit more in depth. This information is also part of the vSAN Observer, but it's also available to the support team. So in this particular case, for every single process that forms vSAN, they can see how it's behaving. What the number of IOPS is, what the latency is, what the throughput is, you name it, all of that information is available. Of course, they can also see what the capacity looks like. And this is something that happens on a regular basis. People, for whatever reason, fill up data stores. So if the data store has been filled up, they can inform you about it, they can tell you to start cleaning things up. The other thing they can look at is, for instance, the virtual machines. There's one thing that stands out here, hopefully, is that all of the data is anonymous. So if you phone up support and you provide them the UUID, they still can't see what the host names are, they can't see what the names of the virtual machines are. You have to provide them what we call an obfuscation map before they can actually see that kind of data. And that, of course, is for security purposes. The other cool thing that they can do is they can go back to a certain point in time. So if you phone them up and say, you know what, I had an issue, let's say 3 days ago, they can actually go back to a particular snapshot of 3 days ago and then point you out what has changed, what happened, or whatever was the problem at that particular point in time. So hopefully that will change the supporting experience to being less frustrating in the upcoming years. Before you can use this, if you are a vSAN customer or if you're not a vSAN customer, I would encourage you to enable the Customer Experience Improvement Program, because this is what enables this level of support, right? And there's more that we are working on actually. It's not just going to stop at what I've just shown you, but what we're also planning for, and this is something that hopefully will be available in one of the upcoming releases, is to allow you to actually create new support requests within the HTML5 interface. So I know you guys don't like to phone up the support team, but in this particular case you don't need to phone up the support team because you can file a support ticket straight from the interface. The nice thing about this is that it's context sensitive, so we'll pick up your name, we'll pick up the issues that are part of the environment, potentially point out what the answers are to the issues that you're facing, and then it will send it over to GSS. GSS will have that information available instantly, and the cool thing about it is what we just saw, that vSAN Support Insight demo, is that they have the same interface available instantly as well. So you created a support request in the HTML5 interface, they simply go to the interface that they have available, click through it, inform you through their particular interface what kind of issues that they've seen. In this particular case, he's going to mention that an advanced setting should have been configured to a different value. A nice pop-up shows up in the HTML5 client, so you don't get anyone on the phone, and you can start making the changes that you need to start making to your environment. And after you make the changes, you can simply inform the support team that the problem has been solved. Now, how cool is that? You don't even need to phone up anyone anymore, right? It solves, hopefully, a lot of problems in the future. Pretty straightforward, and then hopefully it is something that we can introduce pretty soon. But if you think about that, it also means that we as VMware are gathering certain data sets. So the next step for us, of course, will be creating some form of self-driven data center. Not a software-defined data center, but a self-driven data center, where we're actually taking action based on some of the characteristics of issues that we're starting to see in different environments. So you can imagine that if a particular set of customers are experiencing a particular issue based on a certain driver that they have or a particular host, that we can start informing customers about the fact that they may need to upgrade their firmware or their driver to avoid these issues other customers are experiencing. So we can start mining this data as well. So this is something that we are thinking about in the future. So there's two other things that we are working on, and two more projects that I would like to touch on. The first one is called vSAN Data Protection. Now, before we get started, I did some research on this, and there's a lot of research actually available, but 88% of all the unplanned outages are caused by mechanical failures or human failures. And I can tell you that of that 88%, the majority is actually human failures. Now, luckily for us, in a lot of cases, you can recover from those pretty quickly, right? If you have the right tool set enabled, or you have the DR capabilities enabled in your environment. Unfortunately, bad things happen as well. Every once in a while, a fire happens or the data center is flooded. Now, it took me, I don't know, 10 minutes, 15 minutes to Google a picture where we actually see two guys swimming around in the data center. The funny thing here is there's a third guy taking the picture. Just think about that for a second, right? You could be that guy taking that picture. Now, we as VMware, I think we have still some things that we need to solve. And I mentioned this yesterday during the keynote in Dallas as well. I asked the question, does actually anyone appreciate the vSphere snapshots? And there were a couple of customers who said, yeah, you know, I use the vSphere snapshots all the time. Okay, to what level of depth? How many snapshots do you create? Well, maybe one or two, because after that it stops performing. And we know that that's the case. For vSAN, we already introduced the new snapshotting mechanism, and it performs a lot better. So you can easily create 6 or 7 or 8 snapshots, but that's where it stops. If you talk to all of the storage administrators in the room, they will probably laugh when you mention you can create 8 snapshots for a virtual machine. Because a lot of these guys can create hundreds of snapshots of any given one without a performance loss. So that is something that we've been working on internally as well for vSAN. So what we are developing is this new snapshotting mechanism, and this new snapshotting mechanism will allow you to create up to, let's say, 100 snapshots without any performance difference between the first snapshot and the last snapshot. Right? So the performance will be exactly the same. That by itself is pretty cool, but who wants to look at the same interface over and over again and create a snapshot of any virtual machine 10 times an hour? It gets rather painful fairly quick. So what we're also developing is this new mechanism where you can specify within policy how often we should snapshot a particular virtual machine. So we'll give you the ability to specify in a snapshot that you would like to snapshot that virtual machine 8 times per hour. So that is something that we are developing. On top of that, what we're also developing is the ability to specify where the data should be stored. Because it's nice to have 100 snapshots locally, but if your data center has been flooded, those local snapshots are going to be useless. So they need to be available somewhere remotely. So in this particular interface, we'll also give you the ability to specify where the data needs to be stored. That could be an NFS data store, could be something like data domain, maybe a different vSAN data store. It could basically be anything. Okay, that sounds cool, but what does it look like? Again, I have a demo, and this particular demo, what I'm going to show you is vSAN data protection, and I'm going to create 2 policies. Within the first policy, I'm going to specify the local protection. Within the second policy, I'm going to specify the local protection and the remote protection. So this is the first policy I'm going to create. This is what the policy interface looks like today as well in the HTML5 interface. So it's fairly straightforward. If you've seen this, then you probably are familiar with it. I'm going to select vSAN as the available storage. And then what I'm going to do next is I'm going to select the data protection options. So I'm going to select local data protection, and then I'm going to specify how many snapshots I would like to create. I create a snapshot every 5 minutes, and every 12 snapshot needs to be crash consistent. On top of that, I would like to retain 48 snapshots. So after 48 snapshots, there will be a rollover of the first or the oldest snapshot. And that's it. Now I've simply created a policy, and the only thing I need to do next is assign a policy to a virtual machine. Or multiple virtual machines. That could also be the case, right? So the next policy is where we have local protection and remote protection. So in this particular case, the data will also be offloaded to a different location. If anything has happened to the data center, you can still recover the data. So I'm going to go through the same interface again. I'm going to select local protection and remote protection. But now I see something differently. Yes, I can still specify how often the snapshot needs to be created and what the retention should be locally, but I also have an archive data protection section where I can specify how many hourly snapshots I would like to keep, how many daily snapshots I would like to keep, and how many monthly and yearly snapshots I would like to keep. So you have some particular form of data retention. Now keep in mind that this is still a snapshotting mechanism. So I'm not trying to sell you a backup or recovery solution. That is something entirely different. But in this case, we have snapshots for fast recovery, as I like to call it. So we've created these snapshots. I've already have a couple of virtual machines running, and I already assigned one of these policies to a virtual machine. Because I want to show you what it looks like when you actually recover a virtual machine, when you like to restore a particular virtual machine. So in my interface, I have 2 virtual machines. I'm simply going to click the virtual machine and then look at the interface that shows you how many snapshots you have. Now there are 2 different interfaces here. The first interface is actually part of the virtual machine itself, and it will show you through a way of different colored dots what type of snapshots are available. Depending on the color, the snapshot will be either application consistent, or it may not be an application consistent, a normal snapshot. So the interface, it's difficult. It actually shows it on that side, something this on this particular side, but the interface actually shows you a snapshot and actually shows you what the size of the snapshot as well. But I'm going to restore it through a different interface. I'm just going to right-click the virtual machine. After right-clicking the virtual machine, I'm going to go to vSAN and then click Restore. This is literally all that it takes. I can now select the point in time that I would like to recover from, and then something cool is going to happen, because I can now start deciding where I would like to restore the virtual machine. I can restore the virtual machine in the same cluster, but I can also restore it in a different cluster, a different folder. I can even restore it to a different network. On top of that, I have another decision to make, which is if I would like to restore it as a linked clone virtual machine or as a full virtual machine. Of course, the added benefit of a linked clone is that it's going to power on extremely fast, because we don't need to restore the full data set. So that is something that I'm going to do. On top of that, what I'm also going to specify is that the network doesn't need to be connected, because if the network is connected and we have the same IP address popping up twice on the network, it gets rather painful. So in this particular case, I'm going to restore the virtual machine without having a network connected. So hopefully, that will make your life a bit easier in the future when it comes to disaster recovery. So I'm going to click Next, restore the virtual machine, and now we'll have a linked clone virtual machine up and running instantly. Literally takes less than a minute for you to restore the virtual machine and start doing the test that you need to do. But then the question typically comes is, okay, that sounds cool, I now have this linked mode virtual machine, but what if I would like to promote it to a normal virtual machine? Because it actually contains the data, or contains the data set that I need, and I would like to delete the original virtual machine and would like to continue using this particular virtual machine. Well, you can do that in the interface as well, of course. You simply right-click the interface, you go to vSAN, you say promote, and now what's going to happen is we're going to promote this particular virtual machine to being a full virtual machine. So in the back end, the data will be copied over, will be available for that virtual machine, and the other virtual machine can now be deleted. So that is what we've developed. But that's not what we're going to stop. Because a lot of customers are asking us the following. They said, well, that sounds really cool, but if I create snapshots and I need to offload my snapshots to a second location, that also means I need to have a second location, or potentially a third location. And that is rather costly. So what about these Amazon services? Can we potentially use Amazon S3? And that is something that we are considering. And the cool thing about Amazon S3 is, in this particular case, that we may be able to connect it to VMware Cloud on AWS. So if you would like to restore the data, you can potentially restore it into VMware Cloud on AWS. The added benefit being that the traffic that you're producing in this particular case is east-west traffic. For those who don't know, placing data into Amazon S3 is rather cheap. Getting data out of Amazon S3 is rather expensive. That's where Amazon makes their money. Ask any of the backup administrators in this particular room, or ask any of the storage administrators. They probably know about that fact. But in this particular case, because VMware Cloud on AWS actually sits in the same data center, or in the same availability zone, we can pull the data in without any additional cost. And without having the need for you to run those hosts without having any particular workload. So we don't spin them up when you actually need the workloads to be available. Okay, then there's one more thing, because this is also another question that always pops up. Okay, what about file services? Because we have a traditional storage system, and we also have some file shares or whatever it is, and we are experiencing a lot of challenges. So what are these challenges? Well, it's typically management complexity. For file services, we like to have something similar as vSAN provides. Policy-based management, similar interface, HTML5 client. On top of that, we have some scalability issues, because most of the file services solutions out there are not scale-out file services. So can we have something that is scale-out? And of course, there's a cost aspect involved, at least usually for your managers. But then there's another thing, and I asked this question yesterday as well, so it will be interesting to see where you guys stand. But this aspect of the world of applications changing. Is anyone already doing anything with containers? Okay, it's very similar to what I've seen in Dallas. It's very similar to what I've seen anywhere else in the world, except for Palo Alto. If you ask this question in Silicon Valley, everyone will raise their hands. There's also the skewed reality that some of our development team or product management team has for that obvious reason. But reality is, over time, things will start changing. Now, what a lot of people don't realize is when we talk about cloud-native applications, a lot of people talk about stateless. However, if you look at the top 10 applications that actually are cloud-native and run within a container, 7 out of them actually need to store state in some shape or form. And guess what? You guys are probably end up being responsible for that. So where is it going to be stored? Well, it typically doesn't consume a data store or a LUN, but it usually consumes some form of file share, right? So that is also something we need to take into consideration. So this is something that we are now actively working on. It's also something that's going to be available in beta pretty soon. Both vSAN data protection as well as vSAN file services, so we are pretty far along. The plan here is the following. We should be able to provide you a very similar experience as what we've provided with vSAN so far. It should be easy to manage, it should be able to scale out, and hopefully it's something that you're willing to use. But the cool thing is the following, and I'll show you that in the demo in a second, but the cool thing is the following. So what we're actually developing right now is a storage services platform. It's not a file services platform, but a storage services platform. For now, the first storage service that we'll make available is going to be NFS. The second may be SMB, but in the future can also imagine that we'll be able to do something like S3. Or potentially one of our partners should be able to do something like S3, or maybe a blockchain, or whatever it is. All of that should be available through the same platform. It's simply a framework that we are developing. The first option will be available through VMware, but if partners would like to create other options, that should also be possible. So that is going to be hopefully available soon. So what does that look like? Well, you've already seen the interface a couple of times, so you probably should be familiar. You're probably familiar with the interface by now. But this is simply what it looks like. The first thing we're going to do is we're going to enable vSAN file services. And as we are enabling vSAN file services, it's going to deploy a couple of virtual machines. Those virtual machines need to be connected to a domain, and we need to fill out some of the networking details as well. So we're going to specify the type of IP version that we're using, the subnet mask, the gateway, and then we're going to autofill all of the IP addresses that those virtual machines will have. These virtual machines will be agent virtual machines. So you as an administrator are not managing those. These are simply deployed by VMware, they are managed by VMware, they are patched and upgraded by VMware as well. We will click Finish, and now File Services has been enabled. But this is just File Services itself. Of course, there's another thing that we will need to do, because the next thing that we will need to do is create a file share. Right? We've all done this at some point in time, so it's nothing special. I'm going to show it anyway, so you get a feeling about what it looks like. And if you have any particular feedback around what you've just seen, I would like to know after the session. So going to create a file share. It's available in the same interface as where vSAN is available. We simply click File Services, we're going to click Add, and then we're going to fill out all of the details that you would normally fill out. We'll give it a name, we'll select the storage policy, so we can protect it in any way we like. If it's part of a stretched cluster, we'll select that it needs to be stretched across locations. We'll specify the thresholds in terms of quota, and you name it, in gigabytes or the megabytes, depending on what you prefer. We can add some tags, and then we'll start adding some of the security details. So we can specify which Active Directory group has access to this particular file share, read, write, and execute, potentially read and write, or even just read. We can also specify which IP addresses should be able to access these particular file services, this particular file share, I should say, by simply providing the IP addresses in this particular interface. Fairly straightforward, hopefully. We click Next, Next, Finish, and that's it. We've just created a file share based on the vSAN platform. But that's not the cool part. The cool part, in my opinion, is the fact that we now have all of the different monitoring capabilities also available. So vSAN health monitoring, for instance, will also be available for file services. We can simply click on health, and if anything has happened to my particular file service or file share, all of that data is available in the same interface. You can simply click on it and see what the status is of the interface. Okay, I realize I've shown you for the last 45 minutes a lot of new things probably. And it's probably going to take, a couple of minutes in some cases, maybe an hour, maybe 2 hours, and then you start realizing what you've seen. If there's any particular feedback, I'm available for a couple of hours at the event. Just look me up and provide me the feedback. I'm more than happy to take it back to the engineering team. But the question probably for you guys is, okay, what's next? What comes after that? After we've solved a lot of the challenges that you're facing today? Well, hopefully, this is going to be next, right? You guys can kick back, relax, and enjoy the easy life once again. And with that, I would like to thank you for attending the keynote this morning, and hopefully you will have a great event. Thanks.